In this video, we will be looking at the sum, difference, and double angle identities. So the first thing we are going to look at is the sum identities. So the first thing that we have to memorize is that sine A plus B is going to equal sine A cos B plus cos A and sine B multiplied by sine B. Cos of A plus B will be cos of A multiplied by cos of B minus sine of A multiplied by sine of B. And lastly, guys, tan of A plus B will equal tan A plus tan B over 1 minus tan A multiplied by tan B. So these three are our sum identities and we have to memorize them. Now let's take a look at the difference identities. So first let's look at sine. So sine A minus B. This will be a minus instead of a plus because we're looking at the difference identities. So sine of A minus B will equal sine A multiplied by cos B. Take away cos A multiplied by sine B. Look at cosine of A minus B. Cos A multiplied by cos B plus sine A multiplied by sine B. And lastly, we have tan of A minus B. And if we expand this, this will become tan A minus tan B over 1 plus tan A multiplied by tan B. Alright, now let's look at double angle identities. First, we have sine of 2A. And these are called double angles because there's a 2 in front of our angle A. So sine 2A, if we expand it, is going to become 2 sine A cos A. So basically 2 times sine A times cos A. Now let's look at cos of 2A. Now cos 2A is different because this can be expanded into 3 different forms. So the first form is going to be cos squared A minus sine squared A. And the cos 2A can also become 2 cos squared A minus 1. And it can also be 1 minus 2 sine squared of A. Alright, now let's look at tan 2A. Tan 2A, if we expand it, will become 2 tan A over 1 minus tan squared A. Alright guys, let's look at a practice problem. So first we have write each expression as a single trigonometric function and solve as an exact value. So here is our expression and we have to try and change this into one single trigonometric function. So that means that we have to use either the sum identity, the difference identity, or the double angle identity. If we go back, we can say that sine A minus B is equal to sine A multiplied by cos B minus cos A multiplied by sine B. Now, this red expression right here has the same formatting as the black equation, because here we have sine, here we have cosine, there's sine here, there's cosine there, here we have cosine, there's cosine, there's sine here, and there's sine here, and the b's here will be 17 degrees, and the a's here will be 48 degrees. So all these guys match up. So that means that we can use this equation here to turn this into a single trigonometric function. So what was our A value? Our A value was 48 degrees and our B value was 17 degrees. So we can rewrite this black expression as sine 48 minus 17, because this is our A place and this is our B place. Now sine 48 minus 17 will equal sine 31 degrees. And if we plug sine 31 degrees into our calculator, we can say that sine 31 degrees is equal to 0.52. So we have turned this expression into a single trigonometric function, and we solved it as an exact value, which is 0.52. Alright guys, here we have another expression, cos squared pi over 3 minus sine squared pi over 3. So in order to change this into a single trigonometric function, we have to use the double angle identity. So we have to say cos 2 of theta, or actually let's say 2 of a will equal cos squared of a minus sine squared of a. This guy right here and this guy right here have the same formatting. There's cos squared and sine squared, and then there's the same angle, pi over 3, and here we have the same angle, the a's. So now we just have to say that this is going to equal cos of 2 multiplied by pi over 3, because our a in this case is pi over 3 here. So what is this now? This will become cos 2 pi over 3. And instead of using our calculators, we can actually calculate cos 2 pi over 3. If we draw this right here, so this, oh my bad guys, straight line, that, so this will be 0, this will be pi, or we can, oh sorry guys, this will be pi over 2, and this will be pi. So 2 pi over 3 will be somewhere here, and then it's going to look like that. So 2 pi over 3. Now what is this angle going to be, guys? This angle is going to be pi, take away 2 pi over 3, which will be pi over 3. If we draw a right triangle like that, since these two have to equal 90 degrees, this will become pi over 6. And if we use a special triangle, this will become 1, this will become 2, and this will become root 3. And since this is in the second quadrant, or quadrant 2, this will be a negative. So what is cos of 2 pi over 3? Well, it's going to be 2, which is our r value, over x, which is our negative 1. So cos 2 pi over 3 will be negative 1 over 2. So therefore we wrote this guy as a single trigonometric function and solved it as an exact value, which was negative 1 over 2.